Now students, fourth video or the fourth part of the propositional logic. In this I'm going to discuss the most important connectives of the propositional logic, and these are conditional and biconditional. But before moving ahead, I want you all to subscribe my channel, press subscribe button and press the bell icon also. Now students, a very important connective, and that is conditional. It is also known as if then, and symbol is this arrow sign, the second one is this and third one is this. Alright, so any of these can be used for the conditional. Operation performed is implication. Implication means if one argument is true, then the other argument is true. That is P conditional. Q means if P is true, then Q is true. So I'll clarify that later. Now P and this symbol Q is read as P conditional Q. Then P conditional Q can also be read as and understood as if P then Q. P is called antecedent and the second proposition Q is called consequent. Always remember that. So whatever is written before the conditional, what is appearing here? P. So that is antecedent. Whatever is appearing after the conditional is the consequent. Always remember that these two terms are very important. After that, P conditional Q will produce false. It's a very important line. P conditional Q will produce false if P is true and Q is false. For all other input combinations, it will be true. Alright, you'll be having much better idea when I will explain that through an example and a truth table. Now students, we have got one example in front of us where it is raining is the statement or proposition. Second proposition is the sky is not clear, and it's raining is being represented through the variable P, and sky is not clear is being represented through a boolean variable Q. Now truth table with two variables P and Q which are representing these above statements. Now here students, you observe whenever the combination is 0 0, 0 1 or 1 1, the output is true, and whenever the P is true and the Q is false, which is in this row number 3, the output is 0 or false. Or we can say that whenever the antecedent is true and the consequent is false, then the P conditional Q will produce the false. But here we have taken this example, so we have to understand this truth table in terms of this example. When we say P is 0, that simply means it is not raining. When we say Q is 0, that means sky is clear. So let me read it out for you. If it is not raining, because it is 0 now, so if it is not raining, then sky is clear. It's quite obvious, so it is 1. Second row, we talk about it is not raining and Q has the value 1, that means sky is not clear. True. Third row has got, it says it is raining. If it is raining, then sky is clear. If it is raining, sky is clear. So it is false or 0. Last one, both are having the value true. Means it is raining. If it is raining, then sky is not clear. So that is true. So with the help of this example, I think everybody has understood it well. Now, one very important thing, suppose I don't want to use the conditional, but I want to express this using or and not, means conditional is being removed. Alright, we may call it conditional elimination. We have eliminated the conditional. So this may be expressed as P dash plus Q or P complement plus Q. This is a very important topic which I will discuss later in the future videos. But as of now, you have to learn this, that P conditional Q may be expressed as P dash plus Q. I hope everybody has understood the conditional, the concept of conditional well. Now students, biconditional. Biconditional is also known as equivalence, or we call it if and only if. Symbols are here. This is the first symbol and this is the second symbol. Wherever you read this or find this symbol, so that will be biconditional. You will read it biconditional. Operation performed is if and only if. Works with more than one proposition. Conditional also works with more than one proposition. Now, equivalence means either both the arguments or propositions are true, or both the propositions are false. This is very, very important. Alright. Students, P biconditional Q results into true when both the propositions are either true or both are false. That simply means both the propositions must possess the same truth values. Either both are true or both are false. Students, this will be read as P biconditional Q. P biconditional Q results into false when one of its component propositions is true and the other is false. So whenever the truth values of two propositions are same, the output or the biconditional will produce true, and whenever the truth values of two propositions are different, so output will be false. P conditional Q may be expressed as PQ or P dot Q plus P dash dot Q dash. So this is a way of biconditional elimination that we'll discuss in the future videos. Now, here P is a variable which is actually representing the proposition you work hard, Q is representing you pass the exam. Now, we look at the truth table. It has got the input combination 0, 0, 0, 1, 1, 0 and 1, 1. Normally in all the two variable truth table, it's there. And now, in the output column, where we have got P biconditional Q, you can see the output is 1, 0, 0, 1. That means wherever the input combination has got the same truth values, you can see first row and the last row, the output is 1, and wherever the truth table input combinations truth values are different, the output is 0. Alright, so here we understand in terms of the given example. So here it's written P0, that means you do not work hard. Q0, that means you do not pass the exam. So you do not work hard, you do not pass the exam. Then 0, 1, that means you do not work hard, you pass the exam. Not possible, it is 0. Then third row, you work hard and you do not pass the exam. That means it is false, not possible. Last one says you work hard, you pass the exam. True. So that is why it is 1. So I hope everybody has understood it well. Thanks for watching. Please do subscribe my channel for more videos.